Welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at an introduction to linear graphs. And here are the lesson objectives. Without much ado, let's quickly look into them. So when we talk of linear graph or a straight line graph, what does it mean? For a straight line graph, it is just a graph that forms a straight line. So its name defines it. It forms a straight line when you plot it on the Cartesian plane. We will plot some right now so you actually know what it looks like. But before that, the key ideas behind a straight line graph is that it represents a linear relationship. Linear relationship simply means it shows that as one quantity is increasing, the other is also increasing. As one quantity is decreasing, the other quantity is also decreasing. In addition to that also, it can rise, it can fall, or it can also be horizontal. So let me draw some few graphs so that you actually look at how a linear or a straight line graph looks like. So with this figure on the right hand side, you realize that we have a Cartesian plane with this line on it, which is in green. Now this is a straight line. It is a straight line. And this is how a linear graph looks like. A linear graph can either be straight, as you see, that is, it is ascending from the left to the right, or it can also be as this. So in this case, it is descending from the left to the right. So it is coming downwards. And then finally, we also said it can be horizontal. So talking of it being horizontal, it can also be like this. These are all linear graphs, you see. But on the other hand, a graph that would bend around like this is not a linear. There are other types of graphs we might consider in the future. So we have the parabola, the hyperbola, circles, and then what have you. But for the sake of these studies, we are just looking at what? The linear graph. So for the linear graphs, they are always straight lines. You see, in this direction or in any of the directions we have spoken about so far. Now, as we would see, in real life, there are so many situations that tend to be linear. Example includes the distance versus time at a constant speed. So we'll be looking at how all these are linear in our subsequent lessons. The total cost versus the number of items, if you plot it on a graph, it can also be linear. Then the salary versus the number of days worked. These are all situations where if we actually represent them on the graph, we'll get linear lines or linear graphs. Now, before we look at some further characteristics of the linear graph, let's do a quick recap or a recall on what we call the coordinate plane or the Cartesian plane. Talking of the Cartesian plane, it has a horizontal axis. So this is the horizontal axis, and it is labeled as what? The x. So that is the x-axis. It also has the vertical axis, which we call the y-axis. On the vertical and then the horizontal axis, there are labels. So there are labels that are determined by what we call the scale. Depending on your scale, we label the x-axis. On the right-hand side, having the positive intervals. Then on the left-hand side, you have the negative intervals. On the y-axis as well, we also do label. So for the upward, that is going up, we have the positive intervals in increasing order with respect to your scale. And then coming down, you have your decreasing order with respect to your scale. In between the axis, we have the origin. These two labels help us to identify coordinates on the plane. So if you take any plane at all, such as what I'm taking here. So let's say I'm taking this point over here. Now, what would then be the coordinate of this point I have taken? You can only determine it by tracing it to the x-axis and also to the y-axis. What do we mean by we trace? So you come to the point and look at where it traces to the x-axis. It means on the x, it is 2. Then on the y, it also corresponds to 2. Hence, writing your coordinate, you're going to write the coordinate in the form x, comma, y. That is where it points on the x and then where it also points on the y. So with this case, the coordinate of this point is going to be 2, 2. As simple as that. This is just a recap. We have gone through these in subsequent lessons. Now, let's look at the main issue here, which is one characteristic of a linear graph. When we talk of intercepts, if you have a straight line, and by now we know what a straight line is, the linear graph. If I draw a straight line like this, you'd realize that the line touches a point on the x-axis and it also touches a point on the y-axis. That is what we call the intercept. So the intercept is simply where your line will touch on the axis, on either axis. Now that gives rise to two types of intercepts. Now with these two intercepts we have, the first one we'll be looking at is the y-intercept. So when we talk of the y-intercept is the point where the graph crosses the y-axis. As we have said, this is our y-axis. So if this is our y-axis, looking at the line we have, where does it cross the y-axis? This is the point where it crosses the y-axis. Now we have identified, or we know how to identify the coordinate. So right here, the x coordinate is actually a 0. And our y coordinate is a 1. It is exactly on the 1. So with this, you realize that anytime you have a line that crosses the y-axis, the coordinate of x is always 0. I can draw many lines so it touches the y-axis, so we see. So as you can see, these are all different lines. This particular line, you would still realize that if this is our y-intercept, it occurs at x equals 0. You see, right on that point. We have already considered this. Now what of this? This is also occurring at where x equals 0. It is not on any point of x, but on x equals 0. There are some lines that, looking at them for the first time, you might think they don't touch the y-axis, as this blue one you see here. But if you are to extend it, you would always get to know where it touches, you see. So if we extend this, you realize that it will still come and touch it somewhere here. And depending on your skill, you identify what point that is. But for the x, it is still 0. So that is one characteristic you should know. The y-intercept always occurs at the point x equals 0. Let's write that down. So as you can see, it occurs when x equals 0. And that should also tell you that it shows the starting value. It shows the starting value because at x equals 0, in our whole number system, it always starts with 0. So that shows the starting value as well. Now, the next intercept we are to take note of is the x-intercept. Talking of x-intercept, as you might have guessed, the x-intercept is the point where the graph crosses the x-axis. So if we take these over here, looking at this blue one, this very blue one, the x-intercept here, we can say, is at -4. So at what point does this line touch the x-axis? And we know writing coordinates, we use the x before the y, that is x, comma, y. So the point here is going to be a -4, then 0. You see, and we can as well identify all the coordinates of the other x-intercept as well. So we have this over here, which looks like a -1.50. Then for this, we have around 4.30. Then what of this? Since it doesn't touch, we would have to extend. And as you can see, the coordinate here is negative, is 2.90. So the x-intercept also has unique characteristics that are worth noting as well. The first being that it occurs when y is 0. So as you might have seen in all that I've written, in all that I wrote here, the y coordinate of all the points were what? 0. Now, it also shows when a quantity becomes 0. So these are the two intercepts you need to take note of. So talking of the types of linear graphs, we'll look at 3. We have the increasing, the decreasing, and the horizontal line or the horizontal graph. For increasing graph, as you can see on our right hand here, you realize that all these lines we have here slope upward from left to right. You see, so this slopes upward from left to right. We have this, which also slopes upward from left to right, and then this as well, which also slopes upward from left to right. Now, as the value of x increases, the y also increases. That is what we are saying. That is what we mean by an increasing graph. In the course of time, we'll be looking at what gradients are, and you realize that when we talk of increasing graph, then we simply mean the gradient of the graph or of the line is positive. So increasing graphs are simply those with positive gradients, or they are the line whose slope upward from the left to the right hand side. Talking of decreasing graphs, the only different thing about the decreasing graph is that the lines slope downwards from the left hand side to the right hand side. So as you can see, the lines are sloping downwards. In the course of time as well, if you learn gradients, you realize that decreasing graphs are those with negative gradients. Their gradients are what? Negative. Now you also say as x increases, the value of y also decreases. As x increases, the value of y also decreases. Then the very last one we want to make mention of is the horizontal graph. So looking at what we have here, you realize that the lines are just horizontal lines. Now, in as much as your x values are changing on each point on the line, the y, on the other hand, remains constant. So at this point, the y is still whatever it is here. At this point, even though you have x being -4, y still remains the same point. X being -3, y still remains just as it is, and it appears for all. That is the characteristic feature of a horizontal line. The y stays constant and it doesn't change. We can say there is no change in output. These are the 3 types of what graphs we need to take note of. With this understanding, let's see if we can interpret just one or two graphs, and then we can call this session done. So since I wouldn't want this lesson to be too long, we'll just interpret one, and then we'll continue in our next sessions. There's a graph showing the quantity of fuel in John's car till its depletion. And what are we to do? We are to make sense out of it. So looking at the graph we have here, the y-axis has been labeled fuel in liters, whilst the x has been labeled distance, or better still, distance in meters. Looking at it, it simply means that if you are to identify our y-intercept, then we can easily say John started driving whilst his tank, that is the fuel in his car or whatever he was moving with, actually had a 3-liter capacity. So it was 3 liters full. But then as he drove at a distance of 1 meter, we can see the corresponding amount that has gone off. You see, so it continued depleting till he drove for 5 meters. And at 5 meters, you notice that, and at 5 liters, which is our x-intercept, the coordinate of y was what? 0. So the fuel depleted at 5 liters after his first movement. That is the sense we can make out of this data. With enough information, we can even solve other questions as well. So we can even be asked to look for the rate at which the fuel got depleted. That is the rate with respect to what? Liters per distance. And we'll look at that in our next lesson. So we are ending here. And in this lesson, I do hope our objectives have been achieved. By now, you should be able to explain what linear or straight graph means. You should be able to identify linear graphs among other graphs. You should be able to understand our intercepts, that is the x and y intercept. And though we just looked at one of the interpretation, you should get the gist of how to interpret linear graphs as well. Let's have Beyond Numbers, where we learn maths the easy way. I do hope this lesson was helpful. If it was, and this is your first time on this channel, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, where we look at the gradient. Bye for now, and do stay safe.